in today's session, we are going to understand one of the largely used product of the dye industry, and that is chrome blue black. So let's just understand how we can manufacture this particular product. So as you can see here, the blue black dye are the moderate group in which moderate is being required for the dyeing purpose. So what moderate is always required for the dyeing of these processes. The moderate for the chrome dyes is potassium dichromate. So this moderate is being generally used as the potassium dichromate is being generally used as the moderate in this particular dye process. Now it is mainly used for wool fabric and silk and the nylon after this chrome dyeing, but it is also can be used for the wool and a variety of the fiber with the blending of this fiber dye, which gives ultimately shade of black to the navy blue side, right? So to change the shade of black into the navy blue, this particular type of the dye can be very useful. This type of the dye has the advantage that the dyeing process is completed in a single step. So we can conclude we can easily impart our dye on a particular substance in a single step, right? So there is no multiple step required for the imparting of this dye, and which ultimately reduce the time taken for this process, and it also very much easy to matching the different shapes. So this kind of the dyes is being very useful. Now here you can see that the one structure of the moderate black 70, right? You can see here it has two OH groups and it has one amino group which is being connected via two different rings, and we have one acidic group as SO3Na. Now after understanding this, let's just understand what are the different raw material and the chemical reaction that we need to follow for particularly producing this black blue chrome dye. So the basic raw material is 1 amino, 2 naphthalene, 4 sulfonic acid. This particular acid is also being known as 1,2,4 acid, right? It is the main raw material and onto which we are going to implement different functional group and ultimately produce black blue 70. So you have to remember this: 1 amino, 2 naphthalene and 4 sulfonic acid, which is commonly known as 1,2,4 acid. Or we can also use its derivative as well. On the another side, we require beta naphthanol, that is nothing but one kind of the coupler. So by means of this azo dye and with the help of coupler, we can actually produce this particular dye. Then we are going to require caustic soda to manage the pH, and we are going to require sodium nitrate in order to produce this diazo of this particular 1,2,4 acid. Then we require HCl, salt, water, and lastly we are going to require copper sulfate. So let's just understand what is the chemical reaction that we need to follow in order to produce this particular dye. So as you can see here, we are taking 1,2,4 acid, that is nothing but your 1 amino, that is this is the 1 amino, 2 naphthanol, 4 sulfonic acid, right? So this is 1, 2, 3 and 4th position. So it is 1 amino, 2 naphthanol and 4 sulfonic acid is our raw material, right? And on the diazonation with the sodium acid and the HCl at very low temperature of -5 degrees Celsius, we can produce this diazo of our raw material. Then coupling it with the beta naphthol that we have taken, we will ultimately have this chrome blue black dye, right? So as you can see here, our beta naphthol is being interlinked with this particular dye and it will produce the chrome blue black dye. So this particular structure is nothing but your beta naphthol, right? So now let's just understand what is the actual process description or what is the actual flow sheet for the production of this chrome blue black dye. So as you can see here, we are requiring different chemical reactor in order to produce different solutions. The first reactor in which we are preparing solution of our 1,2,4 acid, that is our main raw material. And we are producing this mixture with the help of water and HCl solution. We are adding some amount of ice so that we can ensure there is minimum temperature of -5 degrees Celsius throughout the addition of HCl. So we have to maintain this temperature so that this reaction do not carry forward, right? We are also adding sodium nitrate in one more solution. Now we are producing beta naphthol solution in another reactor and we are producing solution of HCl. So now simultaneously all of these 4 reactants are being added inside the one coupler. This coupler unit is also being known as the wet unit, in which we have to maintain temperature of -5 degrees Celsius by mean of the ice. So all of these four solution of our raw material are being inserted in this particular reactor slowly, so that we can ensure there is always minimum of the -5 degrees Celsius temperature. Now after this coupling unit, this product coming out of this coupler is sent to the neutralization tank, in which we are neutralizing our mixture by mean of the HCl and with reduced pH. After that, it is being sent to the plate and frame filtration unit, where we recover different filtrate and we recycle. While this slurry is being sent to the tunnel dryer, where we dry our final product at very high temperature of 75 degrees Celsius. And later, after milling, we are getting fine powders of the final product. And it is being sent to the mixture unit, where we add salt in order to get particular desired purity of our final product. And lastly, we will get the chrome blue black as the final product. So this was the entire flow sheet that describes the production of the chrome blue black as the different steps. Let's just quickly understand this flow sheet one more time. So initially we are preparing 4 different solutions in a 4 different tank like this, right? Let me just take a pen here. We are preparing 4 different solutions in this particular segment, right? The first one is our main raw material. Then we are preparing solution of sodium nitrate, then beta-naphthol and HCl. All of these 4 solutions are being mixed inside this coupler unit, which is also being known as the vat, in which we are adding ice to maintain temperature of -5 degrees Celsius. After this reaction mass is being sent to the neutralization tank, in which we are neutralizing it with the help of HCl. And later we are filtrating in the plate and frame filtration. And after that we are drying our slurry, and ultimately we are mixing it with the help of different salt, and it is ultimately we are getting the chrome blue black of desired purity. Now after discussing that, let's just quickly understand what different process description of this particular method. So as you can see here on the screen, that this first step is the diazo preparation and the coupling. So in this step we have to prepare our diazo. This diazo initially is being prepared from 1-amino 2-naphthalone to 4-sulfonic acid, that is your 1,2,4 acid. Is being mixed with the water and salt in a vessel. Now in the another vessel we are preparing sodium nitrate solution with the help of water. And in the another vessel we are preparing beta-naphthol solution, which is being prepared by the stirring, and we have to heat it for the 60 degrees Celsius with the help of steam. And we are also adding caustic soda so that we can ultimately have dilute solution so that our beta-naphthol can be easily dissolved in this caustic soda solution. Now we are also preparing one more mixture of the HCl, which is being carried out inside the another tank. All the solution are being cooled to 5 degrees Celsius, and they are being added inside the vat in the respective order. So this vat is nothing but your coupler vessel, inside which we are adding all the mixture at -5 degrees Celsius. So also we are adding ice in order to maintain this temperature of -5 degrees Celsius for the 2 hours. As you can see here, also ice is being added to maintain this temperature in this coupler unit. So first this diazo of 1,2,4 acids is being formed, and then it is being coupled with the beta-naphthol, and thus we are getting sodium salt of this chrome blue black dye. Now after this step, the second step is the purification and the separation of our chrome blue black dye. The sodium salt of this chrome blue black dye is being neutralized with the help of HCl, and we have to maintain certain pH so that this precipitate of our final product dye can be easily taken out. Now this precipitate of the chrome blue black is being collected by the means of the filtration unit, which is being again used as the plate and frame unit, right? So this where the solid liquid is being separated. Now liquid is being sent to the effluent treatment, and solid is then again sent to the tunnel dryer, which operate at 75 degrees Celsius, where we get the fine powder of our product. And then this fine powder is then sent to the milling unit, where we get the fine granules of our final product. And after which we are adding some salt so that we can ensure there is a sufficient amount of the purity in order to maintain required purity of our particular tank. So with this particular method we can produce around 3,500 kg of the chrome blue black that can be obtained easily from 1,200 kg of the 1,2,4 acid. So which gives ultimately yield of 80 to 85%. Hence, this concludes the production method of this chrome blue black dye. Now, let's just quickly understand what more product of this dyes and intermediate, and that is H acid. This H acid is basically intermediate product in order to produce different dyes. So let's just understand what are the properties of this H acid. As you can see here, this chemical name is H acid, that is nothing but 1 amino, 8 naphthalene and 6 sulfonic acid. It has molecular structure as C14H21, nitrogen and oxygen. It has molecular weight of 379.3 grams per mole. It is very much soluble in water, ether and different alcohols. Its appearance is slightly yellowish and crystalline powders. So this is the chemical structure of H acid. As you can see here, we have one naphthalene ring which has basically two different benzene rings, onto which we have one group as the OH and another group as the NH. Then we have two sulfone group as like this SO3H. Now after understanding this, let's just quickly understand what are the different raw materials that we are going to require in order to produce this H acid. As you can see here on the screen that we are going to ultimately require sulfuric acid to get two sulfone group on these benzene rings. And we are going to require 62% of the oleum and we are going to also require nitric acid. Combinedly, all this mixture is being known as the mixed acid. And then we are going to require iron for the reduction purpose and acetic acid. And we are going to require HCl, caustic soda, lime water and soda ash. So these are the all raw material that we are going to require for the production of this H acid. Now after understanding this, let's just quickly understand what is the chemical reaction that is being taking place in order to produce this H acid solution. As you can see here, we are taking this naphthalene and this naphthalene is undergone through the sulfonation reaction in which we are adding sulfuric acid. Then we are reacting it with 62% of oleum at very high temperature of 150 degree to 180 degrees Celsius. Again, this reaction is highly exothermic reaction, which ultimately give us naphthalene of 3,6,8 trisulfonic acid. So as you can see here, 3 sulfonic group has been attached on the 3, 6 and 8 position of the naphthalene, which is being then sent to the nitration unit in which we add HNO3 of highly concentrated acid with the help of the mixture of sulfuric acid. This reaction takes place at the 40 degrees Celsius. Again, we have to maintain this particular temperature as this reaction is very highly exothermic. Then it will ultimately give us 1 nitro-naphthalene 3,6,8 trisulfuric acid, which basically look like this. Now we have to send to this reduction unit in which we have to replace one of the nitro or the sulfonic group into the OH group. So the reduction is being taking place with the catalyst of iron and AS at the temperature of 90 degrees Celsius. So on the reduction, this particular element will be now reduced to NaO, right? So this particular sulfonic acid group is being replaced with the NaO. Now after this isolation process, this NaO can be replaced with the OH group, where this NaO will mix with the HCl solution that we are going to add in this particular cell, and it will generate water and HCl solution. Now after understanding this chemical reaction, let's just quickly understand what is the flow sheet for the production of this H acid. So as you can see here, we are going to require different types of the vessel. In the process of selecting this vessel, we have to particularly focus on their material of construction, as this particular vessel of the sulfonic acid is need to be manufactured from the cast iron vessel. Since this sulfuric acid and oleum is very highly exothermic and they are being very acidic, so that they can be easily corrode any material. So in order to reduce this corrosion effect, we have to use cast iron vessel, inside which we are adding our naphthalene and we are also adding sulfuric acid and 62% concentrated oleum. With the help of anchor type of the stirrer, we are continuing to maintain temperature of 180 degrees Celsius. Now this reaction mass is then sent to the nitration unit in which we add nitric acid and sulfuric acid, or we can say mixed acid, at the temperature of 40 degrees Celsius. We have to ensure that this temperature do not exceed to the 40 degrees Celsius, which means we have to continuously supply the chilling water outside the surface of this reactor. So this reactor has to be made up of the jacketed type, right? So in order to we can always maintain 40 degrees Celsius temperature of this reaction mass. So this nitration mass, or we can say reaction mass, is then sent to the neutralizing tank where we add soda ash and the lime water in order to maintain pH of this reaction mass. This reactant is also being facilitated with the jacket type and with the anchor type of the acetate. This particular reaction temperature is around 80 degrees Celsius. Now after neutralization tank, we are sending it to the filtration unit in which we filter our slurry and the solid particles. Then after filtration, this filtrate is sent to the reduction vessel where we achieve reduction and we convert one of the sulfonic acid group into the OH, right? So the sulfonic acid group is now being replaced inside this reactor, that will be replaced by the ONA group, right? In which we add iron as the catalyst and soda ash for the replacement of the NO. This particular reaction is being carried out at temperature of 90 to 100 degrees Celsius. And that this reduction mass is sent to the one filtration unit in which we separate our iron catalyst and recover iron, right, in the form of this sludge. This sludge can be directly sent to the landfilling method or it can be sold out for the different gypsum industries. Right, so after that the filtrate unit is sent to the fusion reaction and then it is being sent to the isolation reactor. In this isolation tank, we are adding sulfuric acid so that we can replace this NO group, that is your ONO group, with the help of the one hydrogen, so that we can ultimately have hydroxyl group at the top of the one of the benzene ring of our naphthalene. And then later it is being sent to the filtration unit of the plate and frame filtration. After that, it is being sent to the centrifuge so that we can remove all the moisture inside this slurry. And then lastly, we are sending it to the dryer where we achieve desired purity of our product and we remove all the moisture contained of our final product. And at the end of this process, we are going to get our H acid as the final product. So this was entire flow sheet for the production of H acid. Now let's just quickly understand what is the process description for this particular process. The initially first step is the sulfonation that we have understood in the previous flow sheet. In this sulfonation, 62% oleum and sulfuric acid is being taken inside the one tank which is being made up of the cast iron. This tank has to be felicillate with the jacketed sulfonating reactor which also has the anchor type agitator. Then this acid is being cooled to the 20 degrees Celsius by circulating chilling water inside the jacket. And the naphthalene is being added inside this reactor for the time period of 2 to 2.5 hours. This addition of the naphthalene is in such a way that it does not increase the temperature of the reaction mass by 35 degrees. As we have very well understand the sulfonation in this previous flow sheet, so I am not repeating all these things in a repetitive. After the addition of naphthalene, we have to heat our reaction mass to the 85 degrees Celsius by means of this steam. Then after this heated solution of this reaction mass is again being heated to 150 to 180 degrees Celsius and maintain this temperature for 30 hours to prepare a solution of naphthalene 368 trisulfonic acid that we have seen in the chemical reaction. Then we have to cool our reaction mixture to the 40 degrees Celsius by means of the cooling water. And after the sulfonation group, the next step is our nitration reaction, in which this sulfonated naphthalene is being transferred in one more cast iron jacketed sulfonating reactor which also has the anchor type of agent. Inside which we add nitric acid or the mixed acid, that is mixture of nitric acid and sulfuric acid is being added to this reactor. By doing this, we are also circulating chilling water inside the jacket as well in order to maintain temperature of 40 degrees Celsius for the time of 12 to 13 hours. Now after that, we have to maintain temperature of 40 degrees Celsius for 3 to 4 hours one more time, which ultimately produces 1 nitro naphthalene of 3,6,4 trisulfuric acid. Now after this nitration step, next step is the neutralization and filtration, in which the reaction mass of having pH of 1.3 to 1.5 is being transferred into the jacketed neutralization tank which also has one agent. In this solution, we are adding soda ash and the lime water which is being added slowly, and we have to increase the temperature up to 80 degrees Celsius and we have to maintain this temperature for 3 hours with the continuous stirring as well. Then this batch is continuously stirred for 1 to 8 hours and we have to maintain this pH of 6.5 to 7.5 by means of this limestone and the soda ash. Extra soda ash and limestone can be easily added if required for the maintenance of the pH. Thereafter, this sludge is being removed by the filtration unit in the plate and flame fluid. Now after this, our reaction mass is sent to the reduction unit as well, in which initially gaseous acetic acid and iron are being added inside the jacketed reactor which also has one agitator. Then we have to heat this solution for the 90 degrees Celsius temperature and we have to continue to stir this solution. Now add this reaction filtration mass inside the stirrer to maintain the temperature of 90 to 100 degrees Celsius by means of this steam for the time of 3 to 4 hours. And this ultimately completes the reaction of the reduction. And after this completion of this reduction, we have to add soda ash solution slowly inside this reactor for the time of 3 to 4 hours, and we have to still continue the temperature of 90 degree to 100 degrees Celsius, which will generate the precipitate of our reduction mass. Then this reduction mass is being sent to the filtrate to remove iron sludge in the filtration unit, plate and frame type of the filtration unit, right? Which actually contains the coach acid, and then there is this coach acid is being separated out for the further purification. Now this coach acid is being sent to the one reaction unit, that is your isolation tank, in which we produce in which we add 98% concentrated sulfuric acid in order to replace our Na group with the hydrogen group in order to produce this H acid mixture, as we have understood in the chemical reaction and the flow sheet as well. So this reaction is being taking place inside the controlled reaction temperature at 80 degrees Celsius and for the time period of the 4 hours. Then we have to stir the solution for the 1 hour in order to get the precipitate of H acid. Extra acid can also be added to maintain the pH of 1.3 to 1.5, right, which complete the precipitate of the all H acid. So we have to reduce the pH in order to get the precipitate of our H acid. Then this H acid mixture is being cooled down, and then it is being sent to the plate and frame filtration unit, where we recover all the precipitate of H acid, and we are sending it to the one centrifuge, where we remove all the filtrate slurry, and we recover our H acid slurry of H acid, which is being then sent to the drying unit, where we remove all the moisture content, and then it is being packed. So with the help of this process, we can actually produce 512 kg of dry H acid, which can be easily obtained from 500 kg of the naphthalene, with the processing yield of 40 to 45%. So this concludes the production of H acid, right? We have understand this production of H acid with the help of chemical reaction. Then we have understand the flow sheet, and we have also understand this process description as well. Till then, keep watching, keep learning. Thank you.